Everyone, welcome back to Self Learning. Today we are creating an AI powered voice generator using Python. With just a few lines of code, we will convert text into speech and even allow file uploads for generating voice from documents. So let's get started. We need two main libraries, one for text to speech and one for our UI. Install it by typing pip install gTTS and Chainlit. Next, import the necessary Python libraries. First, import Chainlit for our UI. Then, from gTTS, import gTTS for convert text to speech. Then, import OS for managing our files. Then, import time to give unique file names. Before we generate any speech, we need a place to store the audio files. Make sure to create a folder called audio underscore files where all generated speech files will be saved. Then type os.make dirs with a set of parentheses. Inside of it, put quotes. Then type audio underscore files. Then put comma. Then type exist underscore OK equal to true. It will create a folder if it doesn't exist. Whenever a user types a message, we will process it and generate an audio file. This line uses a decorator from Chainlit called at cl dot on underscore message. Cn is an alias of Chainlit. It tells the application to automatically run the next function whenever a user sends a message. In Chainlit, decorator listening for specific events. Here, it listens for incoming messages from user. Now, let me create a asynchronous function. The keyword is async, then function for def, then my function name is handle underscore message with a set of parentheses. Inside it, I will pass a parameter called message. These define an asynchronous function called handle underscore message that takes a message parameter. The async def keyword let us use asynchronous speeches, making the function non-blocking. It's useful when handling tasks that might take time, like reading files or generating audio, so the app remains responsive. The message parameter represents the user input, which can be a typed message or an uploaded file. Let's create a variable called text and assign as none. First, we initialize the variable text and set it to none. This acts as a placeholder before we determine where the text is coming from, either a file uploaded or a typed message. Then, if message dot elements. Here, we check if message.element has any content. This means the user uploaded one or more files. If no file was uploaded, this condition is false and we skip the file processing step. Next, for element in message.elements, we loop through all uploaded files using a for loop. Each uploaded file is represented as element. This allows us to process multiple files if needed, but we will stop after the first valid one. Then, if message dot meme equal to with a set of codes text slash plain colon. We only want to process .txt files, so we check the meme type of the file using element.meme. Text.plain is the meme type for text files. If this matches, we continue to read the file. Otherwise, the loop keeps checking the next file if any. Then, with open function inside of it, the element.path comma, in a read mode, comma, encoding equal to UTF UTF hyphen 8 as F with a colon, then text equal to F dot read. We use Python's open function to read the file. Element.path gives us the file's location. We open it in read mode and specify UTF-8 encoding to handle different characters properly. F.read function reads the entire content of the file and stores it in the text variable. At this point, text contains the full text from the uploaded.txt file. Now enter it and give a backspace that type break. Finally, we use break to exit the loop after successfully processing the first valid.txt file. This way, even if the user uploads multiple files, we only handle the first one and skip the rest. If no valid.txt file is found, text remains none and we will handle that later. Now, exit from these both if statement that type if text is none with colon. Here we check if text is still none. This would be the case if no valid.txt file was uploaded. Remember, earlier we set text to none by default and only updated it if we successfully read a file. Then type text equal to message dot content dot strip. Since text is none, we assume the user typed a message instead of uploading a file. Message.content gives us the text message typed by the user. We use .strip function to remove any extra spaces from the start or end of the message. These ensure we handle clean input even if the user accidentally adds extra spaces. Then get out of the if statement, then create one more if statement if not text Here, we check if text is empty using if not text. This condition becomes true if text is either none, an empty string, or just white space. It handles cases where the user didn't upload a file and didn't type anything or the file was empty. Then try avoid cl dot message. Make sure the M in caps, then with a set of parentheses inside of it, content equal to with a set of quotes, type please enter text or upload txt file. Outside of the parenthesis, dot send function is empty, we send an error message back to the user. Avoid is used here because this is an asynchronous operation preventing the app from freezing. Cl.message create a message object with the content please enter the text or upload a txt file. The send method sends the message back to the user immediately. Finally, we use return to stop further execution of the function if the input was empty. This ensures we don't proceed to the text-to-speech conversation step when there is no text. Now, we need to create a unique file name for the audio file so it doesn't get overwritten each time. We will use a timestamp to ensure every file has a unique name. Let's create a variable called file name equal to string with a set of double quotes, then audio underscore files slash, then audio underscore with a set of curly brackets. Inside of it, type int, then a circle brackets. Inside of it, time dot time function. Then outside of the curly brackets, dot mp3. We use Python's formatted string feature, also known as an fstring, to create the file name. Then audio underscore file is the folder where we will save the file, and audio underscore is a prefix for consistency. And then time.time function returns the current time in seconds. Then we wrap time.time function in int to remove decimal points, give us a clean number. The results look like something audio underscore file slash audio underscore 123.mp3. This approach ensures the file name is unique even if multiple users send message at near the same time. Now let me create a variable text to speech as TTS equal to gTTS, then with a set of parentheses inside of it, text equal to the text variable, then lang, which is the language short form lang, equal to with a set of quotes in en as English. Now we are using the Google Text to Speech library or gTTS to convert the text into speech. The gTS function takes two main parameters. Text equal to text specifies the input text that we want to convert into speech. Then language en set as the language to English. We could change it to others supported language like ES for Spanish or FR for French. At this point, TTS becomes an object containing the speech data. And now DTS dot save function with a set of parentheses inside of it call our file name variable. This line is actually generated the speech and save it as an MP3 file. If this step is successful, the audio file is ready to play or send back to the user. Now let me create a variable called part underscore message equal to cl dot message. Make sure the message m is caps, then a set of parentheses inside of it, content equal to the double quotes, say inside of it, generated speech, then comma author equal to assistant. Now let the user know the audio has been successfully generated. We create a message object using cl.message from Chainlit. The author parameter is set to assistant, indicating the response is generated from chatbot, not the user. Then type avoid bot underscore message dot send method. We use await bot underscore message dot send method to actually send the message to the user. Await ensures the send operation complete asynchronously so the app remains responsive. At this point, the user gets a message saying their speech has been generated, but the audio file isn't attached yet. Now we want to attach the generated audio file to the message we just sent. We use cl.audio to create an audio response. It takes two key parameters, name and path. Name sets the label that users will see, making it clear this is the generated audio. Then the path specifies the file path to the MP3 we saved earlier. Then we use .send method to actually send the audio files. Then the for underscore id equal to bot underscore id.id ensures the audio files is linked to the previous message, creating a neat conversation flow. And finally, the audio now appears right below the message saying generated speech, making it easy for user to play or download it. Alright, we have written all the necessary code for our text-to-speech application using Chainlit and gTTS. Now let's run the script and see it in action. Running the application will start a chat-based interface where we can upload a text file or type a message to generate speech. Make sure to type as CL after the Chainlit. To run the app, make sure you are in the correct directory with your script. Open your terminal or command prompt and enter the command Chainlit then run, then your script name. Here my script name is app.py. Then enter it. This command launches a Chainlit and opens the app in your default web browser. I am typing hello world directly into the chat input field. Since we are not uploading a file, the app will use this input for text to speech. When I hit enter, the app should generate an audio response.
Hello world.
Let's pass a txt file to check whether our app is working with the txt files. Now let me pass a message. Okay, that's not.
Audio.
Oops, our app is not working properly with txt files. Occurred because the message object didn't have a meme attribute. Using message.meme was incorrect. Instead of checking the meme type, we now validate the file extension using ends with function. There is a small changes in our code where we need to remove our if element.meme equal to text as line. Here we need to add if element dot name dot ends with a set of parentheses. Inside of it, add a double quotes, then dot txt, then add a colon. Then we need to create a variable to store our element dot path. So file underscore path equal to element dot path. And here with open, you have to change it element dot path file underscore path, like that. Let's import our txt format files. Here I have, then I need to pass something instead of blank message. Then, okay.
Artificial intelligence, AI, is a set of technologies that enable computers to perform a variety of advanced functions.
That's it for today's tutorial. Now you have a working AI powered voice generator. If you found this helpful, don't forget to like, subscribe, and comment below what would you like to see next. Stay tuned for more AI project on soft learning.